The vastness of the Milky Way is often compared to that of the Andromeda Galaxy, which is known to extend further across space. Andromeda has an impressive diameter of about 220,000 light-years, surpassing the Milky Way's estimated size of 100,000 to 175,000 light-years. This makes Andromeda a truly monumental structure, occupying an enormous region of space. The challenge of accurately measuring the mass of galaxies, especially in the core of the Andromeda Galaxy, is highlighted by the immense gravitational influence of the supermassive black hole at its center. This black hole exerts a powerful pull on the surrounding stars, causing them to orbit in circular paths, much like planets orbiting the Sun. As these stars approach the closest point in their orbits, called the perihelion, the gravitational forces are strongest, and their velocities peak. At this point, the stars become more densely packed, emitting energy in the form of radiation, including visible light and other types of electromagnetic radiation. This high concentration of stars and the emission of radiation from the supermassive black hole contribute to the bright focal point seen in the center of Andromeda's active galactic nucleus, AGN. An AGN is a highly energetic region at the heart of a galaxy, characterized by intense emissions across various wavelengths, from radio waves to X-rays. These AGNs are powered by the supermassive black hole, which is a region of space with an incredibly dense concentration of mass. When astronomers observe AGNs using advanced telescopes like the Hubble Space Telescope, they note a fascinating phenomenon. The Andromeda Galaxy's AGN has two distinct focal points where radiation is emitted more strongly than in the surrounding areas. One of these focuses is slightly off-center, where the supermassive black hole resides. This black hole has an estimated mass between 110 and 230 million times that of the Sun's. Supermassive black holes are thought to be common at the centers of galaxies, including our own Milky Way, and play a crucial role in the evolution and dynamics of galaxies. When matter, such as gas or stars, gets too close to a supermassive black hole, it forms a rotating disk around it. This accretion disk heats up and emits intense radiation, making the AGN extremely bright. In addition to its AGN, the Andromeda Galaxy is home to an abundance of globular clusters. These are dense groups of stars that orbit the galaxy's center, similar to satellites orbiting a planet. Andromeda is believed to host around 460 globular clusters, each containing hundreds of thousands to millions of stars that formed around the same time. The large number of globular clusters provides valuable insight into Andromeda's vast history and interactions with smaller galaxies over billions of years. It suggests that Andromeda has historically been a galactic cannibal, merging with smaller galaxies in a process known as galactic harassment. When smaller galaxies get too close to Andromeda's gravitational influence, they are torn apart, and their stars are incorporated into Andromeda's stellar population, enriching its diversity of stars. This tendency to accumulate stars from smaller galaxies is common in spiral galaxies like Andromeda, whose structure is ideal for interactions with other galactic companions. Recent studies have sparked speculation among astronomers that the Andromeda Galaxy may be undergoing a significant transformation. It seems to be shifting from a typical spiral galaxy into a rarer type known as a ring galaxy. Ring galaxies are intriguing cosmic objects characterized by their circular or ring-like structures, which are composed of bright, young stars, while the center contains relatively little visible matter. Ring galaxies are divided into three main types: nuclear rings, inner rings, and outer rings. Nuclear rings are located near the center of a galaxy, while inner and outer rings are farther away. These galaxies can be classified into two main types based on their ring structures: O-type and P-type. O-type rings have smooth and regular shapes, while P-type rings tend to be more irregular and are often associated with galaxies that have skewed cores. Ring galaxies are relatively rare, with only about 1 in 10 galaxies exhibiting this feature. Astronomers proposed two primary mechanisms for the formation of ring galaxies. First, they can form from the collision of two or more galaxies. Second, a smaller galaxy passing through the center of a larger galaxy can trigger the development of a ring-like structure. An example of a ring galaxy formed through a galactic collision is the Cartwheel Galaxy. Andromeda itself is expected to collide with the Milky Way in the distant future, ultimately merging to form a new, larger galaxy. While this event will be catastrophic on a cosmic scale, its implications for humanity
known
are
as the
not
Milky
yet
Way,
fully understood. Is often considered a smooth and orderly system. The Andromeda Galaxy, our closest neighboring galaxy, has played a key role in transforming our understanding of the cosmos. It's estimated that there are around 100 billion galaxies in the observable universe. This discovery provided undeniable proof that the universe, and the concept of creation, doesn't revolve around Earth. It shattered the belief that the Milky Way was the only galaxy in existence, suggesting that we are only a small part of a vast and complex universe. Over the past century, our knowledge of Andromeda has expanded greatly, primarily through observations made here on Earth. However, with advanced tools like the James Webb Space Telescope, JWST, our perspective has drastically shifted. Recent findings from the JWST have challenged previous ideas about Andromeda, presenting new mysteries that remain unsolved. Historically, the Milky Way was often depicted as a hazy band of light stretching across the night sky, sparking myths and beliefs in various cultures. It was seen as a mysterious and central feature of the cosmos. In the 1920s, American astronomer Edwin Hubble made a groundbreaking discovery using the 100-inch Hooker telescope at Mount Wilson Observatory. He showed that distant clouds of gas previously thought to be part of the Milky Way were actually separate galaxies, each containing billions of stars. One of the closest of these galaxies was Andromeda, also known as M31. The Andromeda Galaxy has a long history of observation, dating back to the 10th century when the Persian astronomer Abdul Alaman Alfai described it as a small cloud in the star charts of the time. His ability to identify this distant object without telescopic aid was remarkable. In 1612, astronomer Simon Marius gave a more detailed description of Andromeda based on telescopic observations, laying the groundwork for future studies of this giant galaxy. In 1764, French astronomer Charles Messier catalogued Andromeda as M31 in his famous Messier catalogue, mistakenly attributing its discovery to Marius, though he was aware of Alfai's earlier work. In the 17th century, Galileo Galilei revolutionized our understanding of the Milky Way by using his newly invented telescope. He showed that the Milky Way was not just a diffuse band of light but a vast collection of individual stars, planets, and other celestial objects. This challenged the prevailing Aristotelian cosmology, which placed Earth at the center of the universe. In 1750, English astronomer Thomas Wright proposed a new theory in his work An Original Theory or New Hypothesis of the Universe. According to Wright, the Milky Way was not a random collection of stars but a flat layer of stars, and he suggested that our solar system was part of this enormous structure. Although Wright's hypothesis was a step forward, it was still constrained by the observational limitations of the time. At that point, astronomers still believed the Milky Way was the only galaxy. In 1864, English astronomer William Huggins made a crucial discovery when he studied the spectrum of Andromeda and observed that it differed from that of a typical nebula. This was key in confirming Andromeda as a galaxy, rather than a cloud of gas. Andromeda is an enormous galaxy, with a mass estimated to be between 1 and 2 trillion times that of our Sun. Despite its size, it is relatively close to us in the vastness of space. Researchers believe Andromeda is about 10 billion years old, making it quite ancient in cosmic terms. This age reflects a long and complex history of formation and evolution, with a theory that it formed through the merging of several smaller protogalaxies. Over billions of years, smaller cosmic entities gradually merged under the force of gravity to create the magnificent Andromeda Galaxy we observe today. For a long time, astronomers believed Andromeda was much larger than the Milky Way. From Earth, it appeared vast, and it was easy to assume that no other galaxy could match its size. However, galaxies are massive structures, and their mass is intricately related to the distribution and movement of stars, gas, dust, and dark matter within them. Determining these values accurately is a challenging task that requires advanced observational techniques. This kind of research was not possible in the 1700s or even the 1800s, which is why these revelations are only now coming to light. Recent studies have led to a reassessment of previous estimates. New data suggests that the mass of Andromeda may be closer to that of the Milky Way than previously thought, though the exact values remain uncertain. If you were to stand in Andromeda and look at Earth, you would see a galaxy of similar size to our own. This new understanding has significantly altered our view of these two massive galactic giants, putting their scale into clearer perspective.